All right, hello everyone. I'm Yash, and I'm going to be talking about Git. The workshop is titled "Get Your Git Together." And before I start, uh, I just want to get a feel for the temperature. So, how many people have coding experience before, or are okay? A good chunk of people. Um, and how many of you have experience with Git till now? Also, a good chunk of people. That's good to see. Um, But this is going to be an introductory workshop. So I'm going to be targeting everyone who has never touched Git before and who don't know what Git is. So I'm going to go pretty slow. If you guys have any questions, just raise your hands. Or if you want me to slow down or go faster, let me know. Yeah, I'm Yash. I'm doing a computer science and business degree at the University of Alberta. And I'm a software developer at a startup called Karma Health. And that's about me. The agenda for today's workshop is going to be these four. The first is what is version control system, the gateway, setting up, and finally using Git. Let's start with what is a version control system. Um, Remember those times when you guys are writing essays and then you just save your file into a PDF and then you have like draft one and then you make some changes and then there's draft two and then draft final and then draft final two and draft final and so forth. It can be a pain. It's already painful when it's just you who is building this one or writing this one file. And then now when you come in as a team and then you're just like 5 people or 6 people building a piece of code together who are writing code for a project, it's going to be very complicated. You can't obviously save files like this. So there's a different way of doing this, and that is using version control. So this way we can track the changes and who has done what, and it's easier to prevent things from breaking. This brings us to how does Git handle versions. So Git is a version control system. You might have heard of GitHub. So GitHub uses Git internally. And Git handles versions by using something called trees. So let's say this circle is a commit. So it's a version of the file or the project that you have saved. Each commit has this hash that's visible. It's just basically a sequence of numbers and letters, nothing fancy there. And then you have this thing called the main branch or the master branch. So you can think of this as a tree, and the main branch is the trunk. This is where the final or the main versions of the code exist. And then as you create new versions of the code, you can create a new commit, which is a new save point in time. And this commit has its own commit hash, which in this case is F3412. So far, so good. Yeah. All right, now the fun stuff is when I want to make my own version of the code and make some changes, maybe this could be adding my own new feature. So what I can do is I can create a branch like I would see in a tree. So this is something that forks off of the trunk, and this could be my own version of things. It has, this would also have its own commit, and the commit would have its own hash. Then someone else can create a new version of code on their master branch, and I can add some new changes to my branch. And these two branches are different from each other. And the head is where you're currently pointing towards in the tree. So the head in this case is this final pink dot, this pink circle. So this is the version of code that you're currently seeing on your code editor, for example. So Git tracks these changes by hashes. So each of these commits, they have a commit message, and then they contain they contain details on the files that have changed. In this case, there have been modifications to file C and file A. The head is the commit that you're actually on right now. So this is the version of code that you're seeing right now, and you can move in the tree wherever you want. So this is one commit before the head. 2 commits before the head and 3 commits before the head. Each of these commits have their own commit message, and they contain details on the files that have changed. For example, in 3 commits before the head, there have been 2 files that have been added, and afterwards there are just modifications going on. That was the theory behind Git. We're going to start working on Git now, hands-on. So I would like for you guys to take out your laptops, maybe try this as we go. I'm going to speed a little through the setup portion of the workshop because of lack of time. If you still face issues with setting up, let me know after the workshop and I can help you out. There's a neat Google Doc that I've put together that is on nat.ltd/git. So you guys can go there and you can follow along as I do different features of Git. If you guys haven't set up yet, you can take a picture of the slide, and this is how you're going to get set up. You will have to go to this website and just download it and install. There'll be some simple setup that will be done, and I'll show you that in a minute. Yeah, the link for the document is on nat.ltd/git, and while you guys pull it up, I'm going to pull out my laptop. All right, this is the Google Doc that you guys should be on. Again, if you missed it, it's nat.ltd/git. And show of hands, who all have the doc pulled up right now? Okay, we have one, two, a couple. I guess I'll wait for 30 seconds. Any questions so far? No questions so far? I think I'm doing a good job then. Yeah. All right, I'm going to assume most of you have the doc pulled up, so I'm going to get into it. To set up, there are first two things that you have to do. The first is setting up Git itself, and the second is creating an account on github.com. You can go to github.com/signup. I'm already logged in, so you won't see this page if you're creating an account for the first time. The second is installing Git. You can go to this link and download it. Once you have it installed, you can set up your name and your user email. This email should be preferably the same one as the one on your GitHub account, because your information on who has done the commits, that's stored within each commit. So then this email and this name will be associated with each commit that you put on to your repository. For people who are not having a technical background and just want to get by, I highly recommend using GitHub Desktop. It's pretty simple to use. You don't need to, especially if you're dealing with private repositories, you don't need to play with SSH keys and all of that. You just open the app and log in, and that's it. It's pretty straightforward that way. Even if you have technical experience and you just don't want to deal with the hassles of Git, just download GitHub Desktop and you should be good to go for most of it. Yeah. Once you have created an account on github.com, we're going to start by creating a repository. You're going to go up on top over here, and I zoomed in a little too much. Yeah, go to the plus sign on the top right corner and go to new repository. You can think of the repository as a collection of code. This could be your project. There are different ways in which people have their own repositories. So let's say you have a website. So then the UI portion could be one repository, the backend with the logic. That could be a second repository. Or you can just go with a mono repo, in which case you have both things in one. For sake of simplicity, you can just think of this as a folder, and we'll leave it at that. You can set a name for your repository. This has to be unique. There's an example here, but I'm not going to use that. You can set whether the repository is public or private, and there are templates that you can use. Yeah, it is recommended that you use a README file, and this has descriptions on what the project is and how you can set up, how you can get it running. And there is a git ignore file, which is a file that tells Git which files to ignore. And then once you have done setting this up, you can go ahead and click create repository. I have one created already, so I'm not going to do that. All right. One interesting thing before I get into the meat of this is cloning and forking. So once you have that repository open, you can see this green icon here that says code. Here you can go and clone it. You can use this to clone it, or you can go and open GitHub Desktop, which I again highly recommend for non-technical users. This is what Git cloning does is basically it creates a local version of the entire repository on your device. So this way you can make changes and then you can push them back onto the repository online. But let's say there is this repository that you like and you want to build a project on top of it, but you don't want your changes to be associated with the main repository. Like for example, there is I don't know, there is a video game and then there's this really cool open source video game that you like. but then you want to make some changes, but you don't want the changes to be associated with the actual game itself. So in this case, you can fork the repository and make your own changes, and it's your own game. Follow the license agreement though. Don't get me in trouble. So you can go ahead and open your terminal, or and yeah, you can clone your repositories running git clone and the name of the repository. You can use this URL. This is the URL you'll use to clone a repository. And yeah, I have that repository cloned already, and I'm using VS Code. For people who don't know what VS Code is, it's just a code editor. It's like a text document editor, like Google Docs for code. Yeah, there's this neat little terminal at the bottom that you can use to run these commands from the doc. Since I've cloned it, I'm just going to get right into it. As you can see, the repository is empty. There's literally nothing that exists here. So we're going to create the first file, and we're going to do that by just going here and creating, let's say, a README file. I'm just going to say hello world, and I've saved the file. As you can see, the file is highlighted in green. This shows that Git has not tracked the file yet. I actually have a neat little meme to explain this point. As you can see, the plain here is a commit. It's a version of the file or of the repository. And each time you make changes, you want to tell Git to actually use those changes. And that's what git add does. So for example, there's a plane and there are passengers boarding the plane. The passengers could be the changes you've made in the repository. So if you don't tell Git to add those changes, then the plane is just going to fly off without those changes or passengers, and you don't want that. So before you save anything, you want to add your changes. So I'm going to do that by running git add, and then, oh, is my terminal visible to everyone? Is it readable? Yeah. Thumbs up. Anyone? Yeah. Thank you. Yeah. So I'm done. I'm doing git add, and then this it's not an emoji. What this basically tells is you go to the main folder of the project, and then you go inside each and every folder inside and add every single file that exists here. So this way you don't miss out on a single file that you want to add. So I'm going to run that. And now you can see that the U next to my file went to an A, which basically means that Git has now added this file. It is tracking this file. I can double check that by running git status. And this shows that there's this one change that is ready to be committed. It shows that I've created a new file, which is why it's in green. That's exactly what we have done so far. Then I'm going to create a new commit. I'm going to do that by running git commit -m, and then there is this quotation marks. So if you recall going to the slides here, there was these, I'm just going to keep it open. Each one of these are commits, and then the commit has a hash associated with it. And along with the hash, there is also commit message that basically makes it easier for other people to understand what has happened in that commit. In this case, an appropriate message would be added readme. So I've committed this file. You have seen that it's in blue now. It looks like a normal file. But when I go on GitHub and I hit refresh, there is nothing that has changed. So what has happened here is this commit, this exists locally on my laptop, and I want this to go online on GitHub. So I'm going to do that by running git push accept. Yeah, this is on the main branch, and now we should have this here. I'm going to hit refresh, and now we have a README file. It's showing a display of a visualization of the file. You can see the file file exists online. So what has happened here is a push. So here you have local changes that exist on your repository locally on your laptop, and then you're sending this online by just pushing the files online. That's git push. Now going back to the slides, you can see this neat little trick called a branch. So branches are when you want to build a new feature. So let's say there is a game and you want to add a new level. So then you want to aggregate all of these changes about that one level in one single place. You can do this by having branches. So a standard is usually having one branch for one feature. I'm going to show you how to do that. You can go to git branch and the name of the branch, which would be new branch, for example. Now I run just git branch and I see all of the branches that exist in this repository. The main is highlighted in green and there's an asterisk here. This basically signifies that we are on the main branch right now. You can switch branches by running git switch and the name of the branch, which is new branch in this case. You can see that my terminal shows the branch, which is pretty handy. But if it doesn't on yours, you can just run git branch and it shows you the branch you're on right now, which is new branch. I'm going to create a new file here, which would be test.txt, just a random file. Just adding some changes here. Now I'm going to add the changes. I'm going to create a commit, my test file. All right, so this, when I go on GitHub, I don't see the branch anymore. That's weird because it exists here. I'm going to try running git push, and then I get an error. And what the error, this ugly looking error says is that the current branch, new branch, has no upstream branch. So what happens here is when you have a repository that exists locally, you want to tell each branch which branch it is associated with online. This branch is being created only locally, so then there is no respective branch online. So in order to tell Git that I want to create this new branch online and that should have that this local branch should be associated with it, I'm going to put the U flag, which is -u, and I'm going to write this thing called set origin, which basically tells Git that, hey, I'm going to tell you this, I want to push this branch, but I want to associate this branch with some other branch that exists online. And I'm going to put the name of the branch that exists online as new branch. Wait, yeah. Sorry, yeah, I just realized what I did. Yeah, the mistake I made was when I did git push -u, I'm telling it to set upstream as the one that is on origin, which is the repository on GitHub. And that should be, this branch should be associated with new branch that exists in origin or GitHub. These are just fancy terms. You don't need to worry about this. You just need to understand how these commands work. Again, if you're using GitHub desktop or even this Git source control section on VS Code, it's pretty easy to do this. You just click buttons like add and commit, and it's pretty simple. But I'm going to walk you through this on the terminal. Now, once I go on GitHub, it shows that there's this branch called new branch that has had recent pushes 2 seconds ago. And when I open all of the branches, I can see that branch as well. Oops. Yep, I see new branch, and the new branch has test.txt, which is the new file I created on this branch. And now you have created a new commit on a new branch. So give yourself an applause, I guess. And now we have walked through branches and publishing your branch. The U flag is for setting as upstream, which basically tells Git to point the local branch to an online branch. And origin signifies that this branch exists on GitHub. And now, once I go back to main branch, I notice that test.txt does not exist on this branch anymore, but it does on new branch. So what has happened here is we are basically at a situation like this on the slides, where there's this commit that exists on this branch and there's this other commit on this branch, and the main branch does not have the changes from this commit. So in this case, you're going to create something called a pull request, which is basically where you're telling that you want to pull these new changes from my branch to this branch called main. You can do this very easily on GitHub by clicking compare and pull request. Usually when you create a new branch, or if you push new commits onto an existing branch, it just puts up this new pop-up. That's pretty handy. So I'm just going to go there, and you're going to be greeted by this page, which is the page to open a pull request. You should set a title for your pull request, which in this case is adding a test file. So where you put your descriptions, this is in Markdown, and I highly recommend that you go very descriptive in these descriptions. So usually when you're working on big features, there might be like hundreds of files that you've created. hopefully fewer files per pull request. But if you're adding many files, you want the person reading this pull request to know what has happened here exactly. So that's why you should be very descriptive in your pull request description. You can also ask people from, like these could be your friends or people working on that repository to review your code. In this case, I'm going to ask Ritik, or maybe not. I guess you don't have access to this. And I'm going to assign this to myself so that someone who is reading the pull request knows that who has been working on this pull request. And as you scroll down, you can see the commits that have happened. There's just one commit here, which is why you just see this one card here. This has the commit hash here, which is the same one as the one you see here. It shows the number of files that have changed, and then as you add more files in this section below, you can see each file that has changed or been added. And it's very handy in the sense that it doesn't show the entire text file, but it only shows the lines that have changed. In this case, there's just one line, so it shows that one line. And then you can click on create pull request. So this is how the pull request works. Normally, you can add settings into your repository on who is allowed to merge pull requests or who is able to review, or whether you need anyone to review before you merge or not. I won't be going into that right now. But what's happening here is you're taking changes from this new branch and you're pulling it into the main branch. And that's what a pull request does. Once I click on merge pull request, there's again a new commit that gets created. This commit has all of the changes in this, and it adds it into the main branch in this case. I click on confirm merge, and the pull request has been merged and closed successfully. So when I go back to the repository and go to the main branch, you can see that there's a test.txt file, and the file has that one line that I added into the file, which shows that it worked. Any questions so far? Is everyone understanding what I'm saying? If raise your hands to show me that you're understanding. That's everyone. So I think I'm doing a good job. Nice. All right. This is a pull request that I've done. Now I'm going to do something interesting here. I'm going to go to this slide. And let's say that I create a new branch from this commit, which is below. And then I add some new changes onto my own commit. But at the same time, there have been some changes that have happened on the main branch as well. This could come from a new branch or someone just stupidly pushing to main. But what happens here is if you're using the same file, if there are changes that are happening on the same file, let's say the test.txt file, on the main branch, there are some changes and there's a different version of the file on my branch. Git can get confused. It doesn't know which file to take. So when I create a new pull request, and I want to add a new commit on top of this, which is basically taken from my branch, you need to tell Git sometimes on what changes have to be taken. Because if these changes are conflicting, like let's say there's a line that I've added, and then someone else has removed a different line, and then now Git can't just automatically merge because there are two versions of the same line. Git is going to create something called as a merge conflict. So I'm going to try and simulate that here for you. I'm going to go to readme.md, this file, and I'm going to make this hello world with an A. So before I do that, I'm going to create a new branch. You guys need to run git pull on the main branch frequently because sometimes there are changes that have happened on the main branch, and these changes won't be reflected locally. So whenever you're going on the main branch, remember to run git pull. This brings all the new changes and the new commits, so you have your local main branch up to date. I'm going to create a new branch here, and I'm going to call that I like conflicts. So I'm on this new branch called I like conflicts. And meanwhile, on the main branch, I'm creating this new version of readme.md that says hello world. And on this new branch called I like conflicts, I'm going to make this into a capital A. I'm going to add these changes, create a new commit. I'm going to push this. Again, I'm using the flag U, and then I'm going to tell it origin. So it knows that I have to associate this branch I like conflicts, which is a local branch, with this one on GitHub that's also with the same name called I like conflicts. When I run this, it creates a new branch and it pushes these commits online. This is what you can see here. It says new branch, this that is associated with this other branch that exists online. Now when I go on GitHub into my repository, I see that there's this new file, new branch with changes, and I'm going to create a pull request. As soon as you click on create pull request, you see this red warning message that says can't automatically merge. And as you scroll down, you can see that there's this one line that has been modified to look like this. And I can't merge it because it's the same line that has two different versions, and Git doesn't know which version to use. So you can go and run this from resolve conflicts here, and Git makes it pretty easy. You can also do this from VS Code. So just to show that, I'm going to run git pull, and I'm going to go to main and get the latest version as well. So what I'm going to do here is try to merge I like conflicts into main. This is basically the same as creating a pull request. And once I do this, I get this message that says auto merging failed. So Git by default, whenever you run a pull request and you merge it, it merges by merges automatically, unless there are conflicts, such as in this case, there are two different files. And as you open VS Code, you can see this file here with this weird lingo here. This is nothing but basically the two branches and their versions of this line. So this is the version from the head or the main branch, because I'm on the main branch. So head, as you remember, that's the latest commit here on the branch you're existing on right now. So this is the version on head, that is the latest commit on main. And then there's this version from I like conflicts, and both of these are different versions of the same line. Now VS Code is pretty handy, so you can just click on accept current change, accept incoming, or whatever. There's also this merge editor that is pretty handy. Now I've zoomed in a lot, so it looks messy, but this basically shows the two different versions of the file from each branch, and this is the result, which is what's going to be visible after you have merged these two. What I'm going to do here is I'm going to accept the current one, which is the one that is on the main branch, and now you can see that it's accepted on this final result. Then I can click on complete merge, and now what has happened is you can see that readme.md has this one version of the file, which is hello world. Now when I run git status, I can see that there are no conflicts that exist right now. So I'm going to add these changes, and I'm going to push these changes online. Oh. Sorry. You need to run git merge I like conflicts. So this completes the merge. You have not. All right, I've not created commit. My bad. So I'm going to create a merge commit, which is merge commit. Now I'm going to run git push. And now this final result that has come from merging these two branches should be visible on main. And you can see that main from local has gone to the one online. So now when I go on GitHub, you can see that the merge has been successfully merged. The pull request has been successfully merged. And now when I go on the repository, you can see that the merge commit exists. And readme.md shows hello world. And that is how you merge conflicts. Merging conflicts is very important because as you're working in the hackathon and there are like 5 people who are working on the same file maybe, there could be different versions and you're just going to have these very nasty merge conflicts. So there'll be like 50 lines that are different in both of the versions, and then it's just messy. So it helps to understand how merges work and how you can resolve these. I've detailed this in this doc that I've shared with you. You can run git status and it shows which files are conflicting, and then you can open those files and resolve the conflicts. And then once you're done, you're going to run git add, and you're going to create a commit, which is the merge commit, and you're going to push it online. And with that, we come to the end of Get Your Git Together. So I hope everyone has understood whatever I've taught. If there are any questions, you can let me know now or after the workshop. And before I leave you, I'm going to show you this cool thing. So when you go on my repository and I go to commits, you can see that there's this really pretty verified tag here. And by default, you won't have this tag show up. So there is a way for GitHub to know that it is actually you who has created these commits on your behalf. And a hint, you might have to use SSH keys to get the fancy verified tag next to your commits. And with that, we come to the end of this workshop. So, thank you.